All right, middles, it's your turn. Remember, all week we have been comparing fractions using models. Our problem today says, find two fractions that are equivalent to 3/4. And as you know, this week we've been using our fraction strips. So before we begin, I need you to remind me, what does our vocabulary word mean? Yes, we're talking about equivalent. What does it mean for fractions to be equivalent? Did you say equal? That is absolutely correct. Equivalent fractions are the same length. And remember, we used our dotted line to show that our fractions were the same size. So let's begin. The fraction that we know that we're representing is 3/4. 3/4 has a denominator of 4, so we know we're going to use the fourth fraction strips. Let's model 3/4 together. Here we go. There it is, 1/4, 2/4, 3/4. So remember, this is our baseline. We are looking for fractions that are the exact same length as 3/4. Well, in the beginning of the week, I showed you a trick for figuring out which fraction strips to try next. We talked about the term multiples, and we are going to use the denominator to determine which multiples we want to use. Does anyone remember how to find the multiples of a number? That's right, we find multiples by multiplying our denominator by 1, 2, 3, 4, and so on and so forth. So today, we need to identify the multiples of 4. Well, what are they? Did you say 4, 8, 12, and 16? Absolutely. And so how are we going to use our multiples to help us find equivalent fractions? That's right, our multiples become our new denominators. So what is the next set of fraction strips that I'm going to use? Did you say the eighth strips? If you did, you're absolutely correct. So we're going to figure out how many eighth strips it takes to equal 3/4. Let's count them together. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. It takes 6/8 to equal 3/4. So those two fractions are equivalent. Well, earlier in the week, we would look at our next multiple, select our next fraction strip, and then pull our strips one at a time to figure out what the next equivalent fraction is. But now I think you're ready to look at a pattern. So to begin, what multiple are we going to use to figure out what our new denominator is? That's right, we're going to look at the 12. So our next fraction strip that we're going to use are our 12 pieces. Well, we know what our denominator is. Do you think it's possible to figure out what the numerator is without counting our fraction tiles? Well, let's look at the numerators that we already have. 3 and 6. If we already have 3 and 6, do you think there's a pattern that can help us figure out what our next numerator is? 3, 6. 3, 6. Did you notice we were counting by threes? Well, if that's the case, then what's the next numerator? 3, 6, 9. Exactly. So our next fraction should be 9/12. Well, let's pull out 9/12 from our fraction strips and see if it's equivalent. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9/12 is the exact same length as 3/4 and 6/8. Great job, guys. All right, senior scholars, it's your turn. Well, here's your problem. All week, we've been multiplying using area models. In the beginning of the week, we multiplied a double-digit number by a single-digit number. And yesterday, we began multiplying a double-digit number by another double-digit number. And so our problem for today is 34 times 26. Does anyone remember what we do first in order to use our area model? That's right, we write our number in expanded form. So let's start with 34. How do we write 34 in expanded form? Did you say 30 plus 4? If you did, you're absolutely correct. Well, what about 26? That's right, 20 plus 6. Great job. And remember, we use our box for our area model. Remember, when we use an area model, we are multiplying each piece together in order to find our partial products. And then we put our partial products together in order to get our solution. So let's start. We're going to multiply 20 times 30. What is 20 times 30? Did you say 600? Absolutely, because 2 times 3 is 6, and then there are 2 zeros, one from 20 and one from 30. All right, what are we going to multiply next? Did you say 20 times 4? Great job. Well, what is it? 20 times 4 is 80 because 2 times 4 is 8, and then we have 1 0. What should we do next? Did you multiply 6 times 30? Great job. Well, 6 times 3 is 18, and there's 1 0, and so that's 180. And what do we do last? Did you multiply 6 times 4? Absolutely. And 6 times 4 is 24. Great job. We are almost there. So now that we have our partial products, we can take them together and put them together to find our solution. So let's add them now. 600 plus 180 plus 80 plus 24. Take a second to figure it out. If I look at my ones column, I've got 3 zeros and a 4, so I know my ones are going to be 4. In my tens, I've got 8 plus 8, which is 16, plus 2 more, which is 18, so I'd write down 8 and carry a 1, and I'd add 6 plus my carried 1, which is 7, and another 1 would be 8. Therefore, my partial products add up to 884. This means that 34 times 26 is 884. Great job, senior scholars. Well, guess what, guys? Tomorrow is challenge day. You've made it to the end of the week. I hope you've watched all of the videos so far this week to prepare you for the challenge. Not only will I present the new challenge tomorrow, but I will also be shouting out all the students who correctly answered last week's challenge problem. And I'm going to let you know who's going to be winning our special prizes this week. Again, thank you so much for joining. See you tomorrow. Bye-bye.